Good afternoon, folks. This is Mr. Walker here, coming to you with the second half of our notes for special right triangles. Last time on class, we went through the 45, 45, 90 degree triangle. This time, we're going to be talking about the 30, 60, 90 degree triangle. So, let's get into it. All right, we got a quick little investigation that we're going to be looking at. So, what we're looking at are these three triangles. If you notice, they all got the same side lengths. If you remember our names from triangles, that means that all three of these are equilateral. So let's make some things happen. First off, we're going to use these equilateral triangles to create right triangles with an altitude. Now, an altitude is a line that comes from one vertex to the other side that is opposite it. And what it does is it cuts this angle up top in half and these two also in half. So we're going to do that with each of these. Boom and bam. All right. Now, things that we remember, things were cut in half. That angle that that line came out of was cut in half. That side that that line touches is cut in half. So first question here. What are the measures of our new triangles? Let's look at some things. All right, so first off, when you make an altitude, not only does it cut an angle in half, it also cuts a side in half. So we also know that this side here and this side here are both the same. This and this are the same. And so is this and this. Now, we got to go through and determine a couple of things. All right, first off, these are equilateral triangles. Now, equilateral triangles have three angles. And what are those three angles going to be? Now, all three of these have to add up to one number. If you remember in the past, it was 180. So, if all three of these angles are equal, that means that all three of these, for them to add up to 180, means that these angles are all going to be 60 degrees. So, we have this side right here, this side right here, and this original version of the angle up top. These are each 60 degrees. And same thing with the two bigger ones. All right, I'm gonna make sure we note that real quick. We got 60, we got 60, we got 60. Now, along with these 60-degree angles, we got to address the other bits of information that we got. This is an altitude, this line here in the middle. So this line here, in addition with cutting things in half, also makes up a right angle at the bottom right here, where this new vertex is. So what we have here are four, well, it's not four, three sets of right angles. All right, let me try and draw this in there nice and straight as possible. So the question is asking us what are the measures of the angles of our new triangles. We know two of the angles. We have 60, we got 90. We got 60 and we got 90. We need this top one here, okay? So let's go through, let's write this in another ink, okay? Now, this top one right here and right here have to add with the two other angles we have to make up 180 degrees. So I know right now, if I have my 90-degree angle and that 60-degree angle, that's 150, which makes this one, this angle up top, 30. So this line in the middle not only cuts the side on the bottom in half, it also cuts this angle here, this top 60, into two 30-degree angles. That may seem like it was a lot, but it's one thing going into the next. It's okay. So our measurements for this are 30, 60, and 90 degrees. Now, we got one more question. Find the lengths of each altitude. How do we find the lengths of this? So when we try to find the lengths of our altitudes in this triangle, the way that it's set up, this is making a right triangle. Now, there's two ways that we can go through and do this. We can go through this the way that we've been doing with the Pythagorean theorem, or you're going to end up finding a new shortcut today with us. So let's look at how this will work with the Pythagorean theorem. So we know that these two sides here, well, sorry, these three are all the bottom side cut in half. So we got one here, two, and three. Okay. With that in mind, we can go through and find out the length of our altitude. Now you can use either one of the two sides because they're going to be the same. So we can go through and deal with this. So we have in our triangle, let's go through, let's just rewrite this over on the side. In this triangle right now, we got our right angle. Right across from our right angle is C. Down here we got an A and we got our B. So right now we got C and A, but we're missing B. B is that height, that altitude that we got. So let's go and use that information to go through the Pythagorean theorem. All right, so we know when we're missing one of our legs, we have to go through the Pythagorean theorem, and then we have to subtract from our hypotenuse and then take the square root. So for this first one, we got 2 squared plus 1 squared equals b squared. Well, not equals, plus b squared. 2 squared is 4. 1 squared is 1. B squared, we don't know what it is yet. I know I got to get b by itself. So I subtract the 1 to the other side, which is how we get that 3. And then down here, we have to take the square root of both sides, which is how we get the square root of 3. Now, this logic is going to follow suit with these two triangles here. So in the middle, we have c squared equals a squared plus b squared. We got our c and our a. Then we find out what our b is. So you got 4 squared, that's 16. 2 squared, that's 4. You subtracted that. And then what we do right here, we had to actually take the square root of 12 and then simplify it into simplest radical form. Simplest radical form here is going to be our bread and butter going through this. I don't want you to necessarily round with this type of triangle because the radical is going to be a part of the formula for it. So we got 2 square root of 3. Now for the last one, same thing, just a different bit of work. We got 6 squared and 3 squared. That's 36 and 9. I subtract both sides by 9. That's how I got this 27. Now the square root of 27 simplifies into square root of 3 times 3. Okay? So you might have seen a bit of a pattern here. What did we notice about the relationships between the side lengths of these right triangles? If you notice that side length that we try to find in the middle, each had a square root of 3 attached to it. So when we deal with this type of triangle, I want you to keep this square root of 3 in mind. So let's officially talk about what is the 30, 60, 90 degree triangle. So in a 30, 60, 90 degree triangle, the hypotenuse is twice the length of the short leg, and the long leg is the square root of 3 times the length of the short leg. So how do we identify what is the short leg, what is the long leg? If you remember from when we talked about triangles, certain side lengths are across from certain angles. So in a 30, 60, 90 degree angle, we have these three angles, 30, 60, and 90. Now, for us to attach what the meaning is with these angles to these sides, our hypotenuse is across from the side with the right angle. Our short leg is across from our 30-degree angle, and our long leg is across from the 60 because this one here is the middle side right here. So here's our logic for all our sides. We got them labeled. And then the formula for this goes as following. The short leg we call x. Now, the first thing that it told us in the definition, the hypotenuse is twice the length of the short leg. So the hypotenuse is 2x. And then the long leg is the square root of 3 times the length of the short leg. This is the short leg, so this is the square root of 3 times that, which is x square root of 3. So we got two little formulas here. For the hypotenuse, it is twice the short leg. The long leg is the square root of 3 times the short leg. And that's our bread and butter that we're messing with today. So we're going to look at a couple questions together. All right, let's get this. All right, for this, it says find the side lengths for your triangles. All right, first off, let's label a couple things, okay? All right, I got a 90-degree angle, a 60 up top, that's our 30, okay? Our 30 being up top means that this is our short, and this right here is the long leg. All right, now with this being the short leg, this being the long leg, we can find out what x and y are. So our hypotenuse is the side that we got right here. I'm gonna just call this the hype. With this being the hype, we can work backwards to find these two, okay? So let's look at the first little hint that we had. The hypotenuse is twice the short leg. So if 10 is the result of 2 times the short leg, we got 10 equals 2x. And to solve for x, we divide both sides by 2, which means that x is 5. So our short leg down there is 5. Now, the long leg is equal to the square root of 3 times the short leg. If the short leg is 5, then the long leg is just going to be the square root of 3 times 5, or 5 radical 3, so we don't confuse that 5 as being a part of this. So we got x and we got y. Okay. Now, this little formula right here and here, I'll just highlight that one more time. This is going to pop up a couple times with this, but I want you to keep this in mind. Now, this isn't to say that we are done with the Pythagorean theorem. This is still a part of the Pythagorean theorem. This is just a shortcut, and I know you guys love you a good shortcut. So let's take a look at some other ones. All right, up top on this triangle, we have no angle there, but we do have a 30 and a 90 here on the bottom. If this is 30 and that's 90, that means that up top is our 60-degree angle. With that being said, we need to know what side is which. So 9 here is our long angle. X here is our short one, and Y is the hypotenuse. Okay, so they give us the long leg here. So that means that we're going to have to work backwards with the long leg to find the short one. So the long leg is equal to the square root of 3 times the short leg. If that's the case for it, we have 9 is equal to the square root of 3 times x. Now, this is going to require us to have to divide both sides by the square root of 3. And because of that, that means that we are going to have to rationalize the denominator. So that means that we got to multiply this denominator to the top and the bottom of this. So we have square root of 3 times square root of 3. So in the bottom, this is going to turn into 3. And then on top, we have 9 and the square root of 3. Sorry about that, folks. So we got 9 and square root of 3. 9 and 3 both simplified down because that's 9 divided by 3. And that gives you the 3 times the square root of 3, because that 9 and that 3 will just reduce down to 3. Now, if that's what the short leg is equal to, what's the hypotenuse equal to? The hypotenuse is 2 times that. So we got 2 times 3 square root of 3. You multiply just the 2 here and the 3 here. You're going to leave the square root of 3. That's just going to come along for the ride. So that gives us 6 and the square root of 3 for the hypotenuse. So Depending on what you got, you're able to go through and figure out a couple of things. So let's take a look at the next one. We got x here. That's our short side. 4 square root of 3, that is our long one. And y, that's the hypotenuse. Okay. So down here, we got 60, we got 30, and we got 90. All right. So the long side is equal to the square root of 3 times whatever the short side is. We already see the square root of 3 up top there. So we just got to go through and do some division. So dividing both sides of this by the square root of 3 just gives you 4. All right. Now, if that's 4, that means that for our hypotenuse, it is 2 times that short length of 4. 2 times 4, that's nice and easy. That's 8. Boom. All right. Now, for our last one, I'm going to leave that one for you, as well as the practice problems on the very bottom here. Okay? Go through, hit them up, check it up online, and I'm going to catch you guys later. See ya.